Good evening, everyone, and welcome to the Computer History Museum. I'm John Holler, the CEO of this institution, and on behalf of the trustees and our donors and members and everyone involved with the museum, it's wonderful to have you here tonight. This is the second in our series of programs this year celebrating the 40th anniversary of the events that set in motion the birth of the internet and the resulting and profound changes that we're now experiencing every day. I want to start by thanking our friends at Intel who have provided major funding for all 5 programs in the Net at 40 series. Along the way, we're also getting additional support from people like Symantec and, of course, our growing core of members and donors. And if you haven't become a member of the museum, I invite you to do that and to do it tonight. It's a great value for a $60 annual membership, and you will see a large number of additional benefits when our new exhibit wing, Revolution, the first 2,000 years of computing, opens in a new 25,000 square foot wing in just a few months. It's always a special night for us when fellows of the museum are in the audience, and tonight we have with us Doug Engelbart, whose own career was intertwined very closely with that of Bob Taylor, Chuck Thacker, about whom it could be said as well, and who was named last month as this year's winner of the ACM Turing Award, Paul Barron, who is another legend of the connected world. We're glad to have them with us, and if you'd like to know who all the fellows of the museum are, they're outside on the wall, just outside in the vestibule, outside Han. I also want to point out the really fantastic commemorative booklet that we're distributing free at each one of the Net at 40 events. The chief contributor to this booklet is Mark Weber, who is the founding curator of our Internet History program. We are the only major museum in the country to have a program dedicated to the interpretation of Internet history and to the collection and preservation of documents, artifacts, and other historic items associated with the birth of networking and the networked world. And if you'd like to make a contribution of anything related to that enormous breakthrough in technology and society, please see Mark. Finally, I would like to remind you of the other upcoming events in this series. On July 21st, Facebook founder and CEO Mark Zuckerberg will be here, along with David Fitzpatrick, author of the forthcoming book, The Facebook Effect, and Guy Raz, who is here tonight, will be back to interview Mark and David. It's the first time Mark has spoken outside of Facebook events since 2008, so it's going to be an interesting evening. On August 19th, NPR's Laura Seidel will be here to interview Dr. Genevieve Bell, who is one of the nation's leading scholars combining research on demographic trends and on emerging technologies. She is an Intel Fellow and one of the most sought-after speakers in the country on these issues. I also want to mention our 2-day retrospective on the 50th anniversary of Plato, the revolutionary computing system born at the University of Illinois. It forged a path in electronic learning and so much more, and I hope you'll join us for that on June 2nd and 3rd. Now on to tonight's program. Public radio and public museums are enjoying a public boom right now. NPR's audience is up about 50% in the last decade. This is happening at a time when the paid circulation of daily newspapers has dropped by about that same amount, and the audience size of network and cable news is down about 25%. Museum going in this country is up 25% in the last 2 years. Our own traffic growth is exceeding that at a healthy rate. I wonder if that could be due in part to the fact that what started as a trickle and then became a flood of information and is now a torrent also has coupled with it the time that needs a little bit of understanding and that can provide us with a little bit of entertainment when we can all use a little entertainment, but in a slightly different way. In other words, going about the serious business of serving the public good, but without taking ourselves too seriously. Maybe that has something to do with it, and if it does, I hope we succeed in that effort tonight. Given that boom, NPR was therefore the ideal partner for us when we started down the path of celebrating the 40th anniversary of the networked world. And as you can see by the programming lineup, NPR plays a prominent role in this anniversary, and we're absolutely delighted. When we began to think about embarking upon the vast subject matter of the ARPAnet, the internet, and all the innovations and breakthroughs that happened along the way, we quickly realized that we were dipping the teaspoon of history into a fire hose of events. So tonight, we chose a conversation with one of the country's top interviewers and journalists, and Guy Raz, and a name synonymous with the earliest days and rapid development of network communications, Robert W. Taylor. Guy Raz has reported from throughout the world. His portfolio has been as diverse as the Pentagon on the one hand and jazz music on the other. His reporting has been recognized in 2 DuPont Awards and 1 Peabody Award at NPR. He is the weekend host of NPR's All Things Considered and has done that since July of last year. Awards, of course, are quite familiar to Bob Taylor as well. The National Medal of Technology, the Draper Prize of the National Academy of Engineering among them. Not often in the field of technology is the impresario acknowledged in this way, someone who sees opportunity, who provides leadership and funding and ingenuity and synthesis. Those are the traits he demonstrated at ARPA in the 1960s and later at Xerox PARC and at Digital Equipment Corporation. Guy comes to us mostly through your radio, and Bob is a tough guy to get out into the public limelight these days. But we've managed to bring them both live and in person where you can actually see them and listen to them tonight, and I'm pleased to bring them to the stage right now and to get the conversation started. Please welcome Guy Raz and Bob Taylor.
I met Bob last year when we began a series of stories about the net at 40 and about the events that led to the creation of what we now call the internet. And before I continue, I'd like to play a short excerpt from the story we did about Bob Taylor and the ARPAnet.
That was good.
Okay. Now, if you want to know how the internet really began, you have to start in Bob Taylor's tomato garden.
Well, early girls are supposed to be early. This year they were late. These are early girls.
Bob Taylor lives appropriately at the top of a hill in Northern California, overlooking the Silicon Valley, like a creator looking down at his creation. Many historians of the valley would say Bob Taylor's one of the men partly responsible for the tech industry that developed here. And yet technology isn't something Taylor spends too much time on these days. In some ways, he's more interested in tomatoes.
I grow slightly different varieties each year. Well, except for a few standards.
And do you can them or preserve them?
No. I just eat them raw.
And that's how he served them to us when we stepped into his house, a drizzle of olive oil, some salt and pepper. Once a year, when the tomato yield becomes unmanageable, Taylor invites all his old friends up to the house for a tomato feast. The old friends who worked under Bob Taylor at the Xerox PARC Computer Lab in Palo Alto. That team would go on to develop things like the Ethernet, the laser printer, and software that's the basis for the Apple and Windows operating systems. But before all that happened, Taylor worked at the Pentagon's Advanced Research Projects Agency, or ARPA. And that's where, back in 1968, Taylor and his mentor, another computer visionary named Jcr Licklider, wrote a paper that imagined an interconnected computer network. Here's Taylor reading an excerpt from it.
Available within the network will be functions and services to which you subscribe on a regular basis, and others that you call for when you need them. In the former group will be investment guidance, tax counseling, selected dissemination of information in your field of specialization, announcement of cultural, sport, and entertainment events that fit your interests, etc. In the latter group will be dictionaries, encyclopedias, indexes, catalogs, editing programs, teaching programs, testing programs, programming systems, databases, and most important, communication, display, and modeling programs.
That all came true.
Yep, that's right.
Took
a while.
It's a pretty amazing prediction.
No, I don't think so.
Ladies and gentlemen, it is my distinct pleasure and honor to be on stage with Bob Taylor, and once again, I'd like to introduce Bob Taylor.
Thank you very much. Thank you all for coming. I saw a lot of people here that I haven't seen in many years. It was very gratifying, amazing. I guess I should get out more, I don't know. Thank you, John, for your kind words also, and the Computer History Museum for hosting all this. I should thank Intel, a major sponsor. I should especially thank Intel for their 1103 semiconductor memory. At Xerox PARC, we were the first customers of that memory. It was the memory for the Alto. Intel went on after that and did other good things. So where do we begin, Guy?
Well, I'm going to, just a bit of housekeeping before we begin, which is that there are some question cards that you have, hopefully you all have on your seats, and we will take questions about the sort of the last third of our conversation. We're going to focus, most of our conversation will focus on the ARPAnet, but we will, of course, talk a lot about Xerox PARC and about what happened there, because it is so vital and important in understanding the way the internet would go on to develop. So, Bob, I want to start by asking you about John F. Kennedy. Because you told me once, if it wasn't for John F. Kennedy, you probably would never have ended up in Washington, D.C. working for NASA in your 20s. What was it about John Kennedy that drew you to Washington?
Well, I think it's probably a little similar to the spirit in Washington that Obama has created. Kennedy was young and dynamic, and he inspired a lot of young people, I think. Before he got elected, I never considered working for the government. And after he got elected, I was living in Washington, having moved there not too long before he got elected. After he got elected, people had a different attitude about the government. I think people were more hopeful about how things might turn out. So when NASA offered me a program manager's job, I took it.
And this was a job working on flight simulators.
It was a job as a program manager of 3 research programs sponsored out of NASA's Office of Advanced Research and Technology. And these research programs had manned flight control systems, flight displays, and simulation technology as their focus. So my job was to see that these 3 research areas were properly supported both in NASA centers around the country, as well as in universities and certain private research places that specialized in these areas.
Now, I should mention that you had received your undergraduate degree and your master's degree in experimental psychology. Mm-hmm. That was your background. You were not a computer scientist. You aren't a computer scientist. You never studied to receive a PhD. You went and worked for NASA. How did you come to the attention of the Advanced Research Projects Agency at the Pentagon, ARPA, as it was known then? It's now known as DARPA, of course, and specifically a man named Jcr Licklider. How did you come into contact with Licklider and ARPA?
When I was a graduate student, I did research in psychoacoustics. It's nominally a part of psychology, but it's not what people think of when they think of psychology. It's about the study of the auditory nervous system. I was interested in how the brain worked. And the auditory nervous system was the most accessible part of the brain in terms of doing research. Probably the most famous name in the field of psychoacoustics at that time, at the time I was in graduate school, which was in the mid-50s, was a man named Jcr Licklider. He also came out of that same background. My thesis advisor was a friend of Licklider's. I had never met Licklider. In 1957, while I was still in graduate school, Sputnik happened, and that motivated Eisenhower to tell the Department of Defense to start a new research agency so we wouldn't get surprised again like we were surprised by Sputnik. So the Department of Defense started this agency called ARPA. A couple of years later, 1960 or thereabouts, the ARPA programs, which were space programs, because Sputnik had been a space program, were transferred to NASA, which was just then created. That left ARPA with things to look for in other research areas to support. One of the things that ARPA decided to support was computer research. They decided to support a number of other things as well. They hired in late 1962 a fellow from MIT/Bolt, Beranek and Newman named Jcr Licklider, who in the late 50s had gotten interested in computing. And he had built a small group at Bolt, Beranek and Newman, which built one of the first time-sharing systems. Licklider was committed to making computers easier to use. Computers in those days were abominable in terms of ease of use. I mean, you had to go through an unbelievable rigmarole. How many of you have punched holes in cards? You look a lot smarter than that. So so I didn't know Licklider, but I of course knew who he was. And when he came to ARPA in late '62, I was at NASA, and he called a meeting of government people who were supporting research in computing. And I had a little bit of that. I'm jumping ahead of my story, but I'll come back in a moment. But I had read in 1960, I had read a paper by Licklider that changed my life called Man-Computer Symbiosis. Now, prior to reading that paper, I had read, of course, Vannevar Bush's As We May Think, which most of you know about. I'd read a little bit of about cybernetics. But the Licklider paper really gave me a eureka kind of an experience, and I thought that's the way computers ought to be used. Now, this is because, in part, a reaction to when the days I was a graduate student, I took the data from my thesis to my computer center, which of course was a batch processor, and I'd never used a computer, and I said, well, I've got all this data, and I've come here to get it processed. And this guy took me into a room with key punch machines. And there's lots of people in there making lots of racket. And I said, what's all this about? And he said, well, you go to this machine, you type your program into this machine that punches holes in these cards, and you get all these cards together and take them over here. Well, you know what he told me. And I couldn't believe it. I mean, I was appalled, and after I thought about it for a while, I was angry. But I didn't know what to do about it, except I knew I wasn't going to use the damn thing. So I went back to my lab, and I had a Monroe calculator sitting on a desk, on a table, and I sat there day and night typing into that Monroe calculator, processing my data, and that's how I did my thesis. But as I say, I didn't know what to do about it, and this was 1957, and by 1960 I had read this Eureka paper of Lick's. Licklider liked to be called Lick. And then when I was in NASA in 1961, 62, I read another paper. This was a proposal from a fellow named Doug Engelbart, who happens to be here tonight. He's sitting right over there. And I thought, this fellow wants to use computers the way they ought to be used. I'm going to fund him, so I gave him some money. And he needed money at that time. So when Lick came to ARPA and he called together this set of people in the government who were supporting computer research, I was one of them, and he didn't know about Engelbart, so I told him about Engelbart. And so then he began to fund Engelbart as well. And when I first walked into his office, he started, Licklider's office that is, he started asking me about my thesis. And I was totally blown away. How would this guy, famous in his field, know anything about my thesis? My thesis had been published in the Journal of the Acoustical Society of America, which is a physics journal, not a psych journal. And Lick was still keeping up with psychoacoustics work. He had been head of the Psychoacoustic Society at one point. So we hit it off really well right away, and he became my mentor. Then I realize this is a long answer to a short question.
No.
I'm almost there. He after he was there for about a year, he left, and Ivan Sutherland replaced him. And then about a year later, maybe less, he and Ivan convinced me to move from NASA to ARPA. I think your question was, how did I get to ARPA?
That's right, that was. But what really is amazing about that story is Licklider was about at least 20 years older than you. You saw him as kind of a hero. I mean, you had read his work. You had read the man-computer symbiosis paper. You go to his office at the Pentagon in the E-Ring, which must have been kind of intimidating. You were in your late 20s. He had read your thesis. He had read your work. Mm-hmm. I mean, you must have been floored by that.
I was, yeah. He was an amazing fellow. I mean, he could charm the warts off a hog. He was really, yeah.
So he manages to recruit you to ARPA, and you get to ARPA. You're in your early 30s. What did you actually? Before I ask you about what you wanted to do there, just talk a little bit about. And I know a lot of people in this room will know about this, but there are people, believe it or not, who won't know about this. About the timeshare process. I mean, Licklider was really the guy who sort of got that going, right? I mean, he was sort of the guy who thought about the timeshare process and pushed it. So how did it work?
Well, he was dedicated to making computers easier to use, and his particular model for doing that in those days was to take a large mainframe, rewrite some of its software, and connect numbers of terminals to this large single mainframe, and have different individuals at each terminal use the mainframe simultaneously. Hence the word time sharing. They were sharing time on this single large computer. Now there were other models at that time. Wes Clark, who is the designer and creator, I believe, of the first personal computer, was an opponent of time sharing. He believed that people ought to have an individual computer for their own direct use. And he designed and built one. It was called the Link. Is there a link here, John? Do you know? Might be. I don't know. There's one at the DigiBarn, which works, actually. And Bruce Damer of the DigiBarn is here somewhere. There he is. DigiBarn is an interesting place. You should go see it. It's in Boulder Creek. Is that the right town? Yeah. You can find him on Google. Anyway, so Licklider funded a few groups in the United States who were interested in this new way of using computers. Now, in my view, perhaps the single greatest change, benefit throughout the history of computing came when we learned how to make computers interactive. The difference between using a computer interactively and punching holes in cards is night and day. I mean, it's indescribable.
I mean, how did you, as you say, within a short period of time, became the head of the Information Processing Office at ARPA? You had 3 computers in your office.
Well, I had 3 terminals.
3 terminals in your office. So say yes.
To 3 different computers scattered around the country.
Describe what they were for, and describe how those terminals would eventually inspire the idea to think about the ARPAnet.
Well, I can't say that they were the total inspiration for wanting to build the ARPAnet. This is going to be another long answer unless I figure out.
It's the kind of question that is designed to evoke a long answer. Yeah.
As these time-sharing research groups, which Lick funded, and which then Ivan funded after him, and I funded after Ivan, as I watched these time-sharing systems grow at each of these groups, and I visited these groups often, I would run into people who were users who would tell me stories about how they discovered such and such a computer program on their time-shared system that someone else had written, and they'd never met the someone else, but they found the program very useful, and so that led them to meet the someone else, and this phenomenon repeated itself in all of these places over and over again. So what I witnessed was a medium, in this case a time-sharing system, being the causal agent of a community growing. And that was remarkable.
And these people who were using the system didn't know each other. I mean, they didn't. Right.
They would be on the same campus, but they would not necessarily. Some of them knew one another, but they would not all know one another. But they would get to know one another, and they would share experiences. My computer went down, or the computer went down yesterday when I was using it. Were you using it then? What happened? That kind of thing.
And did you think that people should start thinking about about using computers and how to use computers to facilitate human interaction? I mean, was that sort of what?
That was a thought. I mean, that was made obvious to me by these stories that I was hearing. So that's a motivation for building the ARPAnet. That's not the only motivation. I mentioned that I travel to these places frequently, the places I was funding. There were about 12 or 15 of them, but only a few of them were building interactive computing systems. At these places, I would find an individual who would tell me about his research interests, which were very close to the research interests of another individual who was all the way across the country. And I thought, well, wouldn't it be nice if these guys could share programs and data? So that kind of was another motivation for wanting to build the ARPAnet. And finally, back to your 3 terminals question. 3 of the systems that we were funding, one was of the 3, one was at MIT, at Project Mac in Massachusetts. One was at UC Berkeley, Project Genie. And one was at the System Development Corporation in Santa Monica, which was using one of 2 huge, expensive computers that the Air Force had built, called the Q-32. Its maintenance cost was $1 million a year. It's a ridiculous machine. And Lick had convinced SDC to, since this machine wasn't much use for anything else, to build a time-sharing system on it. Well, I had terminals in my office to all 3 of these systems. One terminal for this one for this one, and one for this one. You don't have to be half smart to see that this thing ought to be designed such that you just have one terminal and you can go wherever you want to go.
I mean, you were literally standing up and walking to one, typing something, standing up and walking to another one.
I had 3 chairs.
You didn't have just one swivel chair that you could roll back?
That would have been wise. But not only that, I had to learn 3 different command languages. And why would we have these terminals? I wasn't using the computer all that much, but it came in very handy when I would learn of some new program that someone had written. They would tell me about it, and so I could go to the terminal, log into the system, and use the program, watch it, see it. So it was a very handy thing to have. Anyway, it was one of the motivations, but it wasn't the most important one.
At the time, you had a budget of $18 million, which in today's dollars would be about $110 million. Yeah. It was pretty significant. How did you identify and locate the people you wanted in on this project to develop that system that would allow this interconnectivity?
Before we launched the ARPAnet project, we operated on the basis of receiving unsolicited proposals. So there was a government bulletin that would announce to people who were looking for research support about, they would make announcements about various programs in this field or that field. So people in universities and research organizations would read this bulletin and they would see, well, ARPA has a program office in computing research, and they have a program office in behavioral science, and they have a program office in ballistic missile defense, and they have a program office in nuclear test detection, and I don't know, there are half a dozen others. So they would say, well, I have an idea about this. I think I'll write a proposal to get some of this research money. And that's what an unsolicited proposal amounts to. And so these would come in, and we would read them. And sometimes we would find one that looked pretty good, and so we would go visit them, or we'd ask them to come visit us, and we'd find out more, and then we'd give them money.
And then you also had to identify people. I mean, Larry Roberts was somebody you brought in.
Yeah.
You brought in other programmers to come and work with you on this project. I mean, were you able to sort of...
Well, I should stop you. In the case of the ARPAnet project, this was not based on an unsolicited proposal process. In the case of the ARPAnet, this was something we wanted to generate ourselves. We wanted to drive this process ourselves. So that set a precedent for our office. So I had to set up a number of mechanisms that were quite different than the kind of processes we had been using. So I had to hire a guy who knew about government contracts, and I had to hire a program manager just for the ARPAnet project. That was where Larry Roberts came in. And I had to hire another assistant to help me keep track of all this, because I still had these dozen or 15 other projects in addition to the ARPAnet project. And then on top of that, there were problems developing in the White House because Johnson was running the war out of the Vietnam War out of the White House. So there were problems in Vietnam that I was asked to go investigate and try to fix. So I was a busy fellow. So I brought in Larry Roberts, as you said. Now, Larry Roberts, I knew. How did I know him? Well, he was at Lincoln Lab working on a project that I was funding. That's how I got to know a lot of the people that I got to know, just by traveling around, meeting them, funding them. They would come visit me in the Pentagon on occasion as well. And that's one of the secrets of Xerox PARC, as it turns out, because I spent almost 5 years traveling around the country, meeting some of the smartest people in the field. And then when I started the lab at Xerox PARC, I recruited them.
Which we'll get to, because one of your great talents was you were able to collect some of the best and brightest minds.
Yeah. I mean, the people that I worked with over the years were fantastic. A lot of them are in audience right here.
What's surprising to me about, and again, I mean, you were a very young guy. You were 33, you were running this project that we now talk about in a different way, which we'll get to. But what was surprising to me when we first met was to learn that The universities were not interested. You had to convince the universities to buy into this. They were not interested in being a part of the ARPAnet.
Well, some were, some weren't.
Why were they threatened? I mean, some of them were threatened by it.
Well, computing resources were precious, and nobody wanted to share them with someone else. And here I was proposing a network whereby someone from on the other side of the country could come in and use some of your cycles. Well, that doesn't sound very appetizing. So that's the way some of them felt. Others, especially universities on the West Coast, I don't know, there may be a cultural divide here. SRI, Doug Engelbart's group, thought this was a fantastic idea, this ARPAnet idea. And right away, when I first announced it to a meeting of principal investigators, Doug Engelbart said, we will be the network information center. And they were. So they were one of the first nodes. UCLA didn't have a time sharing system. They had a batch processing system, but they were interested in measurement, networking measurement. So we made them a node because we needed someone to measure this thing as we developed it. UC Santa Barbara thought this was a great idea. And the University of Utah thought this was a great idea. They were interested in computer graphics and ultimately in what networking could mean for that. So those were the first 4 nodes. MIT kind of turned up their nose at it.
And
Which is ironic. Well, that's too long a story.
Yeah, but it puts them in good company because you also went to some of the big tech companies at the time, AT&T, IBM. You approached them, you said, we have this exciting project going. Would you be interested in taking part? And they said no, not interested. Yeah,
well, you must understand that I was pretty sure this thing would work. And I wanted any of the technology that we were supporting from ARPA, I wanted to get it out into the commercial world so that people could buy it and use it, and we would reap the benefits of it, right? So I thought if I could get IBM and AT&T to become nodes in the ARPAnet, then they would experience this new technology, and they would understand it, latch onto it, adopt it, and sell it. And it would be a great thing. So I went to IBM and made this proposition to them. It wouldn't cost them anything. Well, it would cost them some time, and one of their own computers, but they wouldn't have to pay any money. And they said, we're not interested because our computers can already communicate with one another. I thought, Jesus Christ. Yes, but your computers can't communicate with anybody else. What's the matter with you? And not only that, they had rejected time sharing and generally had given ARPA a pretty hard time. The computing industry at large, except for DEC, Digital Equipment Corporation. Okay, this is another long answer, but it's a digression, but I'm going to tell you anyway. That in the 60s, there were 2 important computer conferences, large ones every year. There was a Spring Joint Computer Conference and the Fall Joint Computer Conference. Spring Joint Computer Conference was typically held in the East Coast, and the Fall Joint Computer Conference was typically held on the West Coast. At both of these conferences, for several years, there were always panels set up, these conferences, attacking interactive computing. The industry was doing this. Now, you understand, the industry was wedded to their business model, which was batch processing. So they would have no truck with interactive computing. They knew that ARPA was supporting it, so they would attack ARPA and say that you're wasting lots of taxpayers' money for nothing. This is not what we need. It's inefficient. It's never going to amount to anything. It's never going to go anywhere. So we put up with this for a long time. So it wasn't a complete surprise that that IBM wasn't interested. I went to AT&T. AT&T said packet switching won't work. The ARPAnet runs on packet switching. The internet runs on packet switching. Packet switching works. Now, again, they were dedicated to their business model. They had a huge investment in circuit switching. Packet switching was antithetical to circuit switching. If packet switching worked, what's going to happen to circuit switching? So they weren't interested either. So then later we found out that Xerox wasn't terribly interested. So we had 3 of the largest technical communications companies in the world, AT&T, IBM, and Xerox, who said no. And I suppose they had said yes and had, joined in and threw your resources into making this thing. I wonder if the internet would be any farther along than it is today. I don't know, maybe not. Maybe not, they had their own cultures, and that could have caused a lot of trouble. So maybe it's just as well, but at the time it was damn frustrating.
You needed one of these companies to help you develop what became the IMP, which in our report we sort of described because of course we report to a general audience across the country, we just sort of described it as a router that looked like a refrigerator. You got help from BB&N, a smaller company. How did you approach them, and how did that work out?
Well, we sent out a request for proposals to award a contract for the ARPAnet, and BB&N sent in the best proposal, and so we gave them the funding to build the subnet infrastructure. See. The IMP stood for Interface Message Processor. Each site in the ARPAnet had an IMP sitting next to the main computer for that site, which was referred to as the host computer. The host and the IMP would communicate over here at this site. Then this IMP would communicate directly with this IMP at a different site, which had its host. So all the communication was, before it got to the host, went through the IMPs. This was a brilliant idea given by Wes Clark. Remember Wes Clark? I told you about him earlier. Yeah. Most people who talk about or think about the internet don't realize how important that idea was. What other people who were thinking about the networking architecture as we were designing it were imagining central locations for a single computer in the middle of the country that would control the network all over the country. What a stupid idea. I knew it was a stupid idea, but I didn't have a better one. Wes Clark had a better one. Wes Clark was highly underappreciated by people who are interested in networking technology. By the way, there are 4 people who claim to be fathers of the internet. Now, first of all, you've got to say, what does that say about the morals of the mother? And these 4 people did make contributions to the ARPAnet. The ARPAnet is not an internet, by the way. These 4 people made contributions to the ARPAnet, especially in the area of protocols, which were important. But the elements that make up the ARPAnet, the crucial elements that make up the internet, include the first personal computer that was networked, the graphical user interface, the local area network, the Ethernet, the laser printer, remote procedure call and client-server architectures. None of those things did these forefathers have anything to do with. Nothing. But since 1995, every year around October, typically, one hears about these anniversaries of the ARPAnet, and these four guys raise their hands again. They love breathing their own exhaust. And the reason, one of the reasons I don't want to be called a father of the ARPAnet or anything else except my kids is that I don't want to be associated with that. And one of the reasons that annoys me is it takes credit away from the hundreds of people who really made significant contributions to today's internet. Now, we had the first internet running at Xerox PARC in 1975. We didn't have a browser. We didn't have the World Wide Web. But we had name servers and mail servers and other kinds of facilities, a local area network. We had a protocol called PUP, which stood for PARC Universal Packet, which heavily inspired later developments of TCP/IP. We had about 5,000 users. It was small by today's standards, but it was an internet. An internet is a connection of two or more interactive computer networks. We had three. We had the ARPAnet connected to the Ethernet, connected to the SRI packet radio net. So this isn't mentioned in these anniversaries that come up.
No. And of course, the history is much more complicated, and the historiography is much more complicated, and we probably really won't know the entire story for long after everybody in this room, including
maybe never.
Maybe never. I want to just dial back for a moment because I'm curious about this idea that in a very short period of time, a period of time before instant messaging, before cell phones, text messages, Facebook messages, and so on, and quick telephone calls, you got this project going in about a year and a half. I mean, from start to finish, from the time the ARPAnet?
No, I started it in February of '66, and it got up and running in fall of '69.
It's about 2.5 years, yeah. But which is still about 2.5 years.
February of '66. 67, 68, 69.
3.5 years, sorry, yes. That's why, that's why I'm a journalist and not in this field. But I mean, it is remarkable how quickly that happened. I mean, when you were sort of dealing with people all over the country through letters and phone calls, you got it off the ground so quickly. And I'm wondering if on that day, October 29, 1969, when that first message was sent from UCLA to SRI, did you know at the time that was a significant event? Did you think that it was a significant event?
Not particularly, and the reason is that BB&N had simulated the ARPAnet successfully by hooking up different imps to different hosts back at BB&N while they were building it, and that was a big event because then I knew it worked. The UCLA SRI connection there is also has some humor associated with it. UCLA reminds me they've made a big deal every October. UCLA has about being the people who sent the first message on the ARPAnet. Well, they remind me of the first man who bought the first Model T Ford from a dealer, and he drove it home. And he tried to get his neighbors to believe that he designed it and built it.
enough said. Bob, you finished, the project was successfully completed, and you left ARPA. You left the Pentagon. Why did you leave? I mean, you had achieved this incredible thing. You got all of these amazing minds together across the country. You funded it, it worked, and then you left.
Well, that's one of the reasons. I mean, when I went there, I wanted to make one contribution that I thought was important, and as soon as the ARPAnet worked, that satisfied that objective. Now, there were other reasons. I had been to Vietnam on a number of occasions, and I had learned a fair bit.
And just to clarify, you went to Vietnam. You were basically deputized as a brigadier general, and you went there to help create a system that would streamline the data that President Johnson received, because he was receiving conflicting information, right?
That's right. I wasn't right. The brigadier general is due to the fact that if you work for the Department of Defense and you're a civilian, and you go into a combat zone, you are obliged to be assigned a military rank. That's because it's ridiculous, I know, but if it's according to the rules of the Geneva Convention, if you're captured, the enemy has to know how to treat you, right? So the equivalent military rank of my civilian job was a brigadier general. I've had a lot of fun out of that, because when you're about to go do this, they send you down into the Pentagon to get this ID and get your shots of cholera and all kinds of things. You have to get shots. So I go down there, they take my picture, they give me 2 ID cards, identical. I said, why are you giving me 2 of these? They said, well, if you get captured, you give one to the enemy and you keep the other one. So when I left the Pentagon, I kept one. On occasion, the conversation around drinks and so on, someone will mention something about generals, and I'll say, I was a general. And they'll say, sure you were, yeah. No, I was a general. Oh, have another drink. Get off of it. I said, I'll bet you money I was a general. I can prove it. Okay. How much money? Well, I'll name an amount. Okay, prove it. So I whip out my general's card. I've had a lot of free drinks like that.
Did you? I know that part of the reason why you left ARPA was because you felt that it was increasingly becoming militarized, that the Congress was asking ARPA to stop focusing on projects like the one you worked on and to start focusing more on projects that would benefit the military.
Yes, that happened. And I also, it only took one trip to Vietnam to realize that Vietnam was in the middle of a civil war. We had no business being in Vietnam. The South Vietnamese whom we were supporting were just as crooked and dishonest as the North Vietnamese. There was no good side and bad side in that war. We should never have been there. And if a low-level person like me can go into Vietnam, talk with a few Vietnamese people, understand what's going on, why in the hell couldn't Johnson and McNamara and those guys understand it? The Vietnam War was... It's one of the worst things that we ever did. So that was very discouraging to me.
I mean, you must have been conflicted. I mean, you must have gotten to the point where it was no longer tenable for you to be part of... That's right,
of the military complex. So it was time to leave. And yes, the Congress was beginning to insist that ARPA support mission, what they call mission-oriented research. Mission-oriented research, by definition, cannot be research. Well, it's enough said.
Bob, we're really just scratching the surface of your career because, as you know, I mean, as many of you in here know, if you look at the arc of his career, it begins with NASA, it goes to ARPA at the Pentagon, he goes to Xerox PARC, and on to DEC. And we're really just at the very beginning of your career, and we want to get to some questions. But I want to ask you about just a quick question about something that you have said. You said that the technology to create the internet that we know today was there in 1975. It was affordable by 1985, and it only became something that people began to really use in 1995. Why did it take so long?
Well, a lot of things had to happen. The answer to that is very complicated. First of all, you had to have companies in existence to build the products that were necessary to make the internet work. Those companies did not exist in 1975. They didn't even exist very strongly in 1985. Let me give you some examples. We needed a company that could produce and sell a networked personal computer, ideally with a graphical user interface. Well, we had to wait for Apple to do that. The IBM PC was helpful in that regard. We needed a company to build what we called gateways, what Cisco calls routers. Cisco, we had given Alto Systems, we at Xerox had given Alto Systems to CMU, Stanford, MIT, University of Rochester, 18 Altos, a laser printer, and Ethernet to each of those places. We had put them, we'd given some Altos to the Carter White House and to the House of Representatives. So we had Altos scattered around, but they weren't. None of these were products. And what was needed were companies that were going to make these things into products, and Xerox wasn't going to do that. So Sun, as a result of the Stanford experiences with the Altos, launched a company that launched a product that was based on their Alto experience with the ones that had been at Stanford. 3Com was launched by Bob Metcalf, who worked for me at Xerox earlier, to provide local area network products for people to buy. Adobe was formed by two people who worked for me at Xerox, so that desktop publishing could be available on an internet someday. So these companies had to be brought up from scratch. Then the products had to be brought up from scratch based on not technology they had developed, but technology that had come out of PARC. So that takes a long time.
How were you able to sort of oversee something that became the incubator of all those things? I mean, I know this is going to be a tough question to answer, but in some ways, do you think that one of your great strengths and your sort of inherent talents was the ability to recognize talent in other people?
Yes, but as I said, I had 4 years or so to learn how to do that, and I had a selected set of people to draw from in the first place. So it wasn't as though I had a unknown collection of people from which I had to draw the best and the brightest. I had a set of people who had already committed themselves to doing research usually in interactive computing or something associated with it. And they were at reasonably highly reputable institutions. So I had a select set of people to draw from.
How were you viewed? How was your group, the CSL, the lab that you ran at Xerox PARC? How was your group viewed by the suits at Xerox? Were you seen as a group of, were you seen as a group of geniuses, as visionaries? Did they embrace you? How did they see you guys?
Let's start with the culture. There were cultural differences. Not just between Xerox headquarters and PARC, but even at PARC. Within PARC, there were cultural differences between the computerists and the physicists. The physicists were a straight bunch, by and large. They would come to work at 8 or 9 on time in the morning, and they would go home at 5 in the afternoon, and many of them wore ties.
It's public radio.
I have lots of stories to tell about physicists, but you've all heard them, I think. Then, another cultural story. The first time I visited the Xerox Research Lab in Webster, New York, which was the research lab that was devoted to copier technology, the head of that lab came out to meet me in the lobby, and the first thing he said to me was, the computer will never be as important to society as the copier. On another occasion, a high-level corporate officer from Xerox headquarters was visiting us, and he said to me one day, he said, "If what you're doing is so important, why isn't IBM working on it?" What do you say to some idiot like that? The truth of the matter is that when it came to systems research, IBM couldn't shine our shoes. IBM is a strong company, and they did lots of good things, but systems research wasn't one of them. So we used to say, at Xerox, the selenium tail wags the silicon dog.
Which is really incredible to think that a company that we today, many of us associate with copy machines, really funded this revolution. I'm going to go to some questions that have been thrown out here because they're much better than the ones I have. And this one it speaks to that, which is about Xerox PARC. And the question is, PARC was founded by bright, mostly young researchers. Research labs today often go for established big names, and they rarely hire a whole new team. What's your view on the impact that has on the potential for innovation?
I don't understand the question.
So the idea that Xerox PARC had all these young researchers, very bright, labs today, this questioner says, often go for established names, well-known names.
I'm not sure that's true. Labs today, research labs today, still recruit from new PhDs, just as we did. It's true that if they can hire an established name, they'll do so. Established names help bring in new PhDs. So I don't think it's an all or none process.
This is a question from your time at ARPA. What level of success did you expect from an idea, a proposal, before you would agree to fund it?
That's a good question, and it's pretty easy to answer. The culture at ARPA, imposed not by the program offices, but by the director's office, was if your research program is successful and it can make an order of magnitude difference in the technology that you're researching, then support it. And if it cannot, don't. So we went for big risk items. We didn't support incremental progress, by and large.
I really like this question a lot because it speaks to your interest in existentialism.
We haven't covered that yet.
No, we haven't. It's a very, very simple question, and I'm curious to see how you'd answer. The question is, and I'm going to read it verbatim. Do you have any concerns about what we all have done? Do you have any concerns about what we all have done?
Not many. I think we all have done, by and large, pretty good jobs. Some better than others. I'm fairly optimistic about life in general. I mean, it's true we have a lot of fools in this country. I'm thinking about just this country right now. There's a lot of fools in the world, but that's too big for me to deal with. But then I have to remind myself that the average IQ is supposed to be 100. Now, an IQ of 100 does not mean that that person is very bright. And half the people in this world, in this country, have less than 100 IQ. So it means we have a lot of fools, and we have to do the best we can with them.
Bobby, in a few months, we will have Mark Zuckerberg from Facebook on the stage, and he it'd be interesting to talk to him about privacy, because he has been talking about this issue a lot. You have talked about licensing internet users like we license drivers. Doesn't that open up all sorts of possible problems?
Yes, it does, and I don't know how to do it. I mean, I've said it would be nice if we could figure out a way to do that, but I can't. It seems to me that the costs outweigh the benefits.
So why would you think it should be necessary to license internet users?
Well, you can do a lot of damage. If you're an irresponsible user on the internet, you can do a lot of damage. You can do a lot more damage than if you're an irresponsible driver on the freeway. And so there ought to be some way to control irresponsible internet use. But I don't know how to do it. People are working on it. Maybe someone will figure it out, but it's beyond me.
If ARPA had not funded the ARPAnet, would something like it have been built anyway, and by whom?
I think definitely. As soon as you had interactive computing, I think interactive networks are obvious. It's just a no-brainer. If you've got one computer that you can interact with, which is made possible by a network of terminals around that one computer, then why not a network of computers? I mean, it's just an obvious leap, and not a very big one.
Do you think it would have been done by government or a government agency or a university, or would it have been done by a private corporation?
It's been hard to do it purely privately, I believe. Partly because, as I've already said, private corporations that are successful are loath to embark in new directions. It's very hard for a large corporation to be innovative in a totally new direction. So I think it would probably have to be done by the government, but I don't know.
Bob, just clarify something for us here. Are you a sort of a technology first adopter? I mean, are you the first one in line to get the iTouch and the iPod and the iPad?
No.
No. Have you ever used an iPod or an iTouch or an iPad?
No, and I don't tweet.
You don't tweet. What do you like?
I just recently learned how to conjugate that. I used to say, I used to say I don't Twitter, and someone laughed at me.
What do you like on the internet? I mean, what do you regularly check up on, and what do you like that kind of reflects what you and Lick wrote in the late 1960s?
I like Google a lot. I use Google a lot. I like to play Civilization 4, but that's not an internet. I mean, you can play that on the internet, but I don't. I just play it with my computer, and I do a lot of email. But I'm just an ordinary, fairly modest user of the internet. I'm not an advanced user.
If a younger person, someone in their 20s or 30s in this field, in this industry, was to come up to you and say, Mr. Taylor, what should I be thinking about? What should I be looking at? How should I be thinking about ways to create innovation in this industry? What would you say to them?
I think the most interesting and promising direction for computing will be a merger, a closer and closer marriage between computing technology and biology.
What do you think about, and are you following, the current net neutrality debate?
No.
Fine. That's out the window. What is the key to creating a lab that does groundbreaking research and ships products? Can a lab do both, and if so, how?
No, a lab cannot ship products. A lab can ship technology to a group whose business is to ship products. If the lab thinks it's shipping products, then it's not doing research.
When you worked on the ARPAnet, do you think that the network architecture would have been designed differently had you known that it would become a worldwide network and not just limited to the United States?
I didn't think it would be limited to the United States. I don't think anyone who worked on it in those days thought it would be limited to the United States.
When you were at, I'm going to digress for a moment because I want to go back to the history. We talked about this earlier, but the fourth component of your professional career was at DEC, and I want you to describe a project you worked on there, which was essentially a search engine, right? Mm-hmm. That would sort of become what we kind of use today, the Yahoos and the Googles. What was it?
Well, DEC had 2 labs in Palo Alto, and mine was one of them, and we collaborated on building a search engine called Alta Vista, which was the first really fast search engine and which became the basis for Yahoo's business. Later, the Google search engine from 2 guys at Stanford could compete with ours, and I think it was probably even faster than ours eventually. But the thing that really made Google take off was the fact that they hit on a business model, a way of getting revenue through advertising that was remarkably successful and still is today. And that's really, I think, what distinguishes Google. Now, Google also, in the interim, has hired a whole bunch of really smart people, a lot of whom used to work for me, which is how I know that.
I like this question. It's a great question. I think you'll like it. Who were the top 2 phenomenal innovations, intellects you worked with in your years at ARPA, Park, and DEC, in addition to Wes Clark?
That's an unfair question.
All right, how about 5? and you don't have to rank them in order of importance. You can just throw 5 out.
I'm going to offend someone in this audience if I answer that question. But there were like 50 people, about, at least, I think, in the combination of Xerox, Park, and DEC, CIRC. 50, maybe 75 people who were truly outstanding people in what they did. Many of them, I mean, they weren't all outstanding in exactly the same way. You know, some were strong in this area, others were strong in this area. No one was strong in every area. We were doing computer systems research, and there are many different elements to computer systems research. It would not be possible for one person to be strong in every single one of those elements. You've got to be a great theoretician, you've got to be a great programmer, you've got to be a great designer, you've got to understand all kinds of things about communication software and operating systems, as well as hardware. I can't answer the question.
When you first arrived here to the Silicon Valley in the early 70s, could you have imagined that so much wealth would be created here and people involved in this industry would become international celebrities, Brin's and Zuckerberg's and Page's? I mean, could you have imagined that?
Probably not. I never gave much thought to Silicon Valley. I regret that Silicon Valley is not called Software Valley. We've got a hell of a lot more software in Silicon Valley than we have silicon, and it's software that makes systems hum. But I didn't give much thought to what was going to happen in our local community.
Here's a question from our audience. Even today, much of the internet retains some of its heritage of open, distributed, collaborative work. Is that essential for its success? And did ARPA's approach, either knowingly or not, put that into the internet's cultural DNA?
Yes, absolutely. And Wes Clark had a lot to do with that. Just the mere fact that you've got a distributed architecture through the imps and all that I described earlier means that it's going to be more difficult to instill central control. And so the ARPAnet was deliberately heavily decentralized. And this came from political motivations as well as technical motivations. Another hero of the ARPAnet days that most people don't know about is a fellow named Steve Crocker. His brother is here tonight someplace. And Steve Crocker invented the request for comment process. The RFC. Yeah, right. Right. The forefathers had nothing to do with that either. So the request for comment process was an enormous invention, and he not only invented it, but he managed it. And he was a graduate student in one of our projects. He didn't work for me. He was out in one of the nodes that was going to be part of the ARPAnet. But he did it, and it was very successful. And it meant that all of the people involved in using it were participating in its design. So that works against centralized control.
Out of these three places, ARPA, Park, and DEC, which was the most fun to work at?
Well, that's an interesting question to me. Maybe not to the audience, but, well, they're all completely different. At ARPA and DEC, I had excellent top management, people who supported what I was trying to do. My manager, well, I had two managers at ARPA, but the second one was the one I went to to propose the ARPAnet project. And he kept up with, his name was Charles Hertzfeld, and he kept up with what we were doing in my ARPA office. So when I went in to talk to him about starting this new project called the ARPAnet, he was on board pretty quickly, and he was very supportive, and in 20 minutes he put an extra $1 million in my budget. That was a lot of money in those days. And he took, what's really nice is that he took it out of ballistic missile defense. Ballistic missile defense, in case you didn't know, won't work. Star Wars be damned. So that was really nice, all right? And then I had a lot of good people in the projects I was funding in ARPA, and I had some good people that I brought into my own ARPA office. So that was good for those reasons. At Xerox, I had bad top management, except for one brief period where I had a pretty good manager. But the top management in Xerox didn't understand much about what we were trying to do. And I didn't get much support from him. But at Xerox, I had a set of people whom I recruited who were fantastic. And each of them believed that the other one was fantastic, which made it even greater. You know, it was a lot of fun. It was a lot of fun as long as I could work with my own people. As soon as I had to go upstairs or deal with management in some way or another, it was not so much fun. But at DEC, I had a very good manager. And DEC people and DEC corporate understood what we were doing, whereas many of the Xerox people did not. So that's about the best I can do to answer that question.
We have time for one more question before we have to end this conversation, unfortunately.
Can I tell my favorite software joke before we quit?
Sure. Why don't you tell it now, and then I'll ask my last question.
A lot of you have heard this joke, but I love telling it. So maybe one or two of you have never heard it. That makes it worth telling. So this was a joke that came out of my NASA days. There were a set of people at NASA who cared very much about the weight of the spacecraft that they were launching, and they would come around and weigh the various components of the spacecraft. So a group of weighers showed up one day and said, we're here to weigh the computer for your spacecraft. And so we said, okay, here's the computer. They weighed it. Fine, good. Now we want to weigh the software. And we said the software doesn't weigh anything. And they wouldn't believe me. They wouldn't believe us, I should say. So they argued for a while, and then they finally gave up and went away. A few days later, they came back, and they said, you didn't tell us the truth. We found your software. It's in shoeboxes, in a closet full of shoeboxes, and each shoebox is full of cards with holes punched in them, and all of these cards and shoeboxes weigh a lot. And we said, the software is in the holes.
When historians really begin to talk about this period, let's say 100 years from now, and they have a better grasp of what happened and how this came about, what do you want them to say about you, about Bob Taylor?
They're not going to want to say anything about me. They're not going to know anything about me.
In 1999, when President Clinton awarded Bob Taylor the National Medal of Technology, the citation read, "For visionary leadership in the development of modern computing technology, including initiating the ARPANET project, forerunner of today's internet, and advancing groundbreaking achievements in the development of the personal computer and computer networks." Bob Taylor, thank you so much.
You're a good man. Thank you very much.
You can see for just a second, right? Well, that ovation is for you, Bob, and also Guy, for you. Thank you so much, both of you, tonight. It was just a fantastic evening. We put all of our programming up on YouTube on a branded channel at youtube.com/computerhistory. This will be up in about a week or 10 days. And Bob, I suspect when the people who write the descriptions of events like this for our YouTube channel write the words, they'll say something like, "candid and wide-ranging." So as well they should. I have a gift for both of you. This is a book called Core Memory, which is a set of photographs by a brilliant young photographer named Mark Richards, who has taken fantastic photographs of some of the best items in our collection, including the imp. And I'm going to give one of these to each of you as just a small way of saying thank you very much. I hope you'll be with us on June 2nd and 3rd for the Plato Palooza, as we're calling it, the 50th anniversary of Plato, and on July 21st for the next in our series featuring Mark Zuckerberg and again, Guy Raz. Thank you, everyone, and good night.